Today in geometry, we're going to look at section 8.3. We're going to prove that a quadrilateral is a parallelogram. So yesterday we looked at all of our theorems involving parallelograms. So today we're going to look at the conditions for those. So basically we're going to go the opposite. So theorem, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we can say in this picture, if AB is congruent to DC, and AD is congruent to BC, then we can say that ABCD is a parallelogram. So all of the theorems we talked about yesterday, today, now we're just kind of doing the converse of them. The second one, if both pairs of opposite angles of a quadrilateral are congruent, then that's enough to prove that the quadrilateral is a parallelogram. So we would say if angle A is congruent to angle C and angle B is congruent to angle D, then we can say ABCD is a parallelogram. Our next theorem says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So here I could say if AB is congruent to CD and AB is parallel to CD, if I know both of those things, then I can say that ABCD is a parallelogram. All right, the next one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So I can say if AX is congruent to CX, and BX is congruent to DX, then I can say ABCD is a parallelogram. And finally, our last theorem, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So I can say if the measure of angle A plus the measure of angle B equals 180, and the measure of angle B plus the measure of angle C equals 180 degrees, then I can say ABCD is a parallelogram. All right, so now we're going to work some examples using this. So example number one, it says, show that PQRS is a parallelogram for x equals 21 and y equals 16. Okay, they give me the angles P, Q, R, and S. So if I can prove that opposite angles are congruent, then I can show that that PQRS is a parallelogram. So I'm going to put the measure of angle P is equal to 3 times 21 plus 12. So 3 times 21 plus 12 equals 75 degrees. So now the measure of angle R, they tell me it's 4x, but x they tell me is 21 minus 9. 4 times 21, all of that minus 9 is 75 degrees. So now I need to do angle Q and angle S. So the measure of angle Q is 7 times, instead of y, 16 minus 7. 7 times 16, and then subtract 7, that gets me 105 degrees. Measure of angle S, 6 times 16 plus 9. So 6 times 16 plus 9 gets me 105 degrees. So I've just shown that angle P is congruent to angle R, angle Q is congruent to angle S, therefore I can say PQRS is a parallelogram. So we've got more work to do today than we did yesterday. We have to plug everything in today. Okay. Okay, the next one, number 2, it says show that UVXY is a parallelogram for x is equal to 11. Okay. They give me 3 of the angles. I need to show that my consecutive interior angles are supplementary. Okay. So let's see, we'll find the measure of angle U is equal to 9 times 11 plus 4. So 9 times 11, 99 plus 4 is 103 degrees. The measure of angle V is 7 times 11, which is 77 degrees. The measure of angle X is 11 times 11 minus 18. So 121 minus 18 is 103 degrees. So I see that 103 plus 77 equals 180. So I can say that the measure of angle U plus the measure of angle V is equal to 180 degrees. I can also say the measure of angle V plus the measure of angle X is equal to 180 degrees. Therefore, since I just proved that consecutive interior angles are supplementary, I can say that UVXY is a parallelogram. All right, so the next one is going to be a little bit different. So up to here, these first two, they asked me to show that it was a parallelogram, to prove that it was a parallelogram. So now, number 3, it says for what value of x is the quadrilateral JKLM a parallelogram? And I see that they give me diagonals. I know that in order to be a parallelogram, that my diagonals have to bisect one another. So I would need 4x equal 6x minus 8. If I can prove that, then I can say that my quadrilateral is a parallelogram. So 4x equals 6x, I'm going to move 6x over and I get negative 2x equals negative 8, x equals 4. So when x is equal to 4, JKLM is a parallelogram. Because my diagonals bisect each other. Okay? All right, so now the last thing, we're going to list what are all the ways that we can prove a quadrilateral is a parallelogram. So the very first way, we can show both pairs of opposite sides are parallel. It's one way we can prove it's a parallelogram. Another way we can prove it's a parallelogram is to show both pairs of opposite sides are congruent. That will prove that it's a parallelogram. The next way would be to show both pairs of opposite angles are congruent. That would prove that it's a parallelogram. If we can show one pair of opposite sides are both parallel and congruent, that's enough to show that it is a parallelogram. If I can show that my diagonals bisect one another, I can prove it's a parallelogram. And actually, I need 2 more here. If I can show that my consecutive interior angles are supplementary, then I can say it's a parallelogram. And finally, if I can show that my diagonals create two congruent triangles, I can show that it is a parallelogram. So that is section 8.3, how to prove a quadrilateral is a parallelogram. So you see, we're using everything that we learned in the previous section, and we're just reversing it, basically taking the converse of those theorems. Your homework today is section 8.3. Tomorrow we will start looking at the properties of rectangles.